we've been looking at esters and how we make them from a carboxylic acid and an alcohol. So, but then what we're going to look at this time is what happens when we react a molecule that looks a bit like this. This is what we call ethane 1,2-dioic acid. And it's called that because it has two carboxylic acid groups. So whenever we see the C double bond O, OH on a carbon, that means we have a carboxylic acid.
So we have to write 1, 2.
For this one, yes, but you don't need to worry about naming the actual name of the molecule. Now, we're going to react our ethane 1,2-dioic acid with a compound that looks a bit like this. Any idea what this molecule is called?
Ethanoic acid.
Nope, not ethanoic acid.
Ethanoic.
Nope, remember we've got alcohols?
Oh, 2 alcohols.
Yeah.
Ethanol.
Nearly right. This is ethane 1,2-diol. A diol. Now,
why do we call it di?
because the di means two. So 1 alcohol group, 2 alcohol groups. So what's going to happen when we react our diol with our dioic acid?
They both.
You're going to get esterification reactions happening on each side. So this OH group here is going to react on this side. And let's see what happens when we draw that. We'll get something that looks a bit like this. So just in case that's a mundane bit, there we go. What we can form, so we've got our ester linkage here, our double bond O followed by the rest of the alcohol. The problem with this is we still have a carboxylic acid group and the alcohol group. So what's going to happen then?
So you immerse this whole ethanol with the ethan, which
Yes.
is part of the dioic acid, the carboxylic
Mm-hmm.
acid.
Yeah, so we still have this carboxylic acid group, and this can react with another molecule of the ethane 1,2-diol. So I'm going to draw a line and show what happens. We can form this. But what do we have on either end now?
The same.
Still got alcohol groups, yes. And
Well,
we're going to have more molecules of our dioic acid floating around. What's going to happen?
So it's going to be empty.
Yeah, exactly. So so you're going to make another.
So it gets bigger and bigger.
Exactly.
Which means the reaction is going to be stronger.
Not necessarily stronger, but it'll keep going until eventually what you're going to make?
A clean alcohol.
Not a clean alcohol. You're going to make a very, 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 very long molecule. And these very, very long molecules are called polymers.
But I don't know, when in childhood I had this, I used to play this game, and
Yeah.
it's a card game, and I had a card named Polymerisation, and the effect of that card was fusing two stuff into one.
Ah.
And so I just thought polymerization means fusing.
Well, you're sort of making lots of small bits, not from one very long bit. Yeah. And this type of polymerization, this is what we call condensation. Yeah. And do you know what the name of this molecule is?
Oh wait, that would be 208. That would be,
Remember, it's a very, very, very long molecule.
which means it has a very, very long name.
It might do, but it actually has, it's actually got quite a simple name. It's called polymerisation.
polydioic acid.
That's great, but what type of molecule are we making with this? No, it's carboxylic acid in an alcohol reactor form, and ester. So it's called polyester. Exactly.
Ah.
And that is how polyester is made.